Hey guys, my name is Vishal and I welcome you all to this live session by Edureka. In today's session, we would be talking about Docker on AWS. But before we do that, I hope that you all are in the pinkest of your health and I hope that you all are doing well. Now, I would like you all to give me a quick confirmation whether I'm audible to you people or not. If yes, then quickly say yes in the chat box and we can move further. Also guys, if you do have any queries, you can put those in the chat box and we would get back to you right away. Now this being a short session, we might miss out on certain queries. If that is the case, then you can put in your email IDs as well so that we can get back to you on those queries later. Having said that guys, I can see quite a few people typing yes, so let us not waste any time and quickly just get started with the agenda of today's session first. So as far as the offerings of this session goes, we would be talking about following pointers. First and foremost, I would introduce you to Docker. And to do that, we need to understand two important topics. That is, what is virtualization and what is containerization. So once we've understood these topics, probably you'd be in a much better state to understand what Docker is. Then we would understand what AWS is and how you can use Docker on Amazon Web Services, that is AWS. Finally, I would finish things off with the demo part. I hope this agenda is clear to you guys, so let us not waste any time and quickly get started. So what exactly is Docker? Now first, let us take a look at the basic definition, as in what does the definition has to say. Now, as far as the definition is concerned, it stands for a tool that basically lets you create, deploy, and test applications in different environments. Now, the second line here is very interesting. It says that it is nothing but containers which are lightweight alternatives to virtual machines, and they let you do that on one single OS. Yes, now for people who are completely new to Docker, they might wonder what virtual machines are, what containers are, and what am I talking about creating, deploying, and running applications in different environments. Well, to understand this particular term or these terms, let us first understand what virtualization is. And probably all these terms would make a lot more sense to you people. So let us first understand what virtualization is. Now guys, if you talk about virtualization, this is the scenario that existed before virtualization actually came into picture. Now, to consider computing or to consider software usage or development, we all know that we need a hardware on top of which we have a software and on top of which we run our applications, right? As simple as that. We all use laptops, computers, systems. So what we do is we probably have a system which is your hardware, on top of which you have an operating system which is a software, or basically an operating system which actually lets you go ahead and use your applications, whether it's your Java application, playing some games, playing music, whatever it is. For that, you need a basic operating system which is a software. So when you talk about software development, this is what you need. You need a basic infrastructure, a hardware, on top of which you have an operating system and on which you basically run applications. But when you talk about software development, it is not that simple. I mean, you're talking about n number of applications, n number of processes. Let us consider Amazon. Now when you talk about Amazon, whether it's the e-commerce website, whether you're talking about Amazon Web Services, or the various applications they host on top of their platforms. Now all these applications, they basically have so many parallel applications or small applications running. I mean, e-commerce website, for example, there you have your billing section, you have your different product section, you have customer service, and a number of other sections, right? So having a monolithic application actually makes our architecture very difficult to use, and also for the people who are monitoring it, maintaining it, it is a tedious task for them. The other disadvantage of this particular architecture is that the fact that there are multiple applications or multiple processes running on a single architecture, what it does is it kind of makes all those applications dependent on that particular infrastructure. Suppose if I wanted to use like multiple operating systems or different operating systems to run different kind of softwares. So if I was bound to a particular infrastructure, I wouldn't be able to do that. So what virtualization does is it basically lets you use one infrastructure on which you can run virtual softwares or have virtual environments running parallelly so that you can run different operating systems. To give you a very simple example, we have our laptops, right, in which we have operating systems. What if I wanted to run multiple operating systems? Probably if I can install a particular software, something like a virtualization software, what that would do is that would basically let me run multiple applications on that particular hardware. So this is what virtualization does. It lets me run multiple operating systems, multiple kind of applications in a single environment. But the best part about it is when I'm using it as an individual, I do not realize that I'm working on a virtual environment. Instead, it feels like I'm working on a single system. That means if I'm using an operating system, say Windows, and running a particular software on it, parallelly, if I have one more instance on which I'm running maybe a Mac OS, what I would feel is my Windows OS is running on a different system and my Mac OS is running on a different system. But that is not the case with virtualization. It is actually giving you that feel, but the underlying architecture is one on top of which you are running multiple operating systems and multiple softwares on top of that. Now, if you actually go ahead and take a look at the architecture, this is what it looks like, virtualization in particular. Now, if you talk about a particular virtual machine which runs or is based on virtualization, you would be having a server host, that is your basic hardware, on top of which you'd be having a host operating system and then a hypervisor. Now, what is a hypervisor? Your hypervisor is a middleware or a middle layer. Now, this hypervisor basically it acts as a middleware that communicates with your host applications, not host applications, your host infrastructure basically, and it also communicates with the operating systems or the applications that you want to run on top of it. So what a virtual machine does is it gives you the basic infrastructure, which is must. I mean, no matter what kind of application you are running, you need a basic infrastructure, that is your server where you can actually go ahead and host your applications, and on top of it you have your host operating system. So what virtual machines do is, using this hypervisor, they let you run n number of different virtual machines which would have their own guest OS, which would have their own binaries, libraries, and applications that run on it. So what this approach does is, this basically helps you in to a certain extent where you can actually save in some money and some time as well. I mean, instead of having n number of machines running parallelly, you can have one machine, and on top of that machine you can have various virtual machines. So you're actually saving up costs for running various hardwares or various servers. Instead, on one server you can have various virtual machines. So yes, you're saving costs as well, and the fact that you can switch between different OSs and different instances or environments, that also helps you save time. But again, is this the most efficient way? For certain applications, definitely yes. If you need privatization, you need more private approach towards your applications, towards your operating systems, towards your binaries, libraries, then yes, virtual machine is a good approach. But in case if time is something that is very important to you, probably you wish to save more space, in that case you have a better option. That option is your containerization. Now take a look at this diagram, and probably I would again get back to virtual machines and have a discussion on these topics. Now when you talk about containers, it is similar to your virtual machines. Yes, so here too you have basically a server and a host OS. I mean, that is understandable. As I've already mentioned, you need an underlying architecture. So that is what you have. But on top of it, you do not have a middleware. Instead, what you have is you have a Docker engine. And the best part here is you do not see a guest OS. Directly what you see is you see containers instead of your virtual machines, and even in those containers what you see is you see your applications, you see your binaries, you see your libraries, and those things. So how is containerization better? Well, what containerization does is it actually saves you from certain factors, like you do not need a hypervisor, you do not need a guest OS here. So that means the process, that is your virtualization process, in which virtual machines spawn a completely different guest OS, that takes time. But in case of your containers, that time is saved. How? Because you do not have guest OSs here. So if a virtual machine takes say certain minutes to launch, your so-called container would take seconds to launch. So yes, you're saving time, and the fact that you're not using extra resources. I mean, if you are spawning a guest OS, some space extra would be consumed and would be occupied. That is not the case with containers. So if you talk about more efficiency, yes, containers in certain aspects are more efficient. But again guys, do not mistake me for the fact that I'm saying that containers are better than virtual machines. No, that is not the case. It depends upon the applications. What kind of applications are you using? For certain applications, virtual machines are better. For certain applications, containerization is better. So containerization or containers basically are good enough when you talk about basically when you talk about speed, or you need faster deployment, faster creation and testing of applications. So in that case, containers serve much better. So again, what are the exact differences? Where should you use virtual machines and where should you use containers? Well, that is not the discussion for today. For some other time, probably we would have discussion on those topics. For now, our main focus is containers and Docker. So this is what a container is, and I believe by now you have a clearer picture as to what a container is. And if you go back, you would be able to relate to this definition in a much better manner. So back then I said that Docker is a tool which is designed to make it easier for you to create, deploy and run your applications. Now using containers, that actually becomes true. And the fact that containers are lightweight alternatives to virtual machines, probably this sentence is making a lot more sense to you people now. So yes, this is what Docker is. It basically lets you spawn these containers using which you can actually create, deploy and run your applications much faster by using containers. So again, what is the other benefit, or what is the anomaly that Docker containers overcome? Now, if you all know what DevOps is, which is an approach that brings in developers and operations team, what DevOps strives at is basically bringing in these two teams. Why? Because developers normally develop softwares and operations team probably maintains those softwares. So when you talk about maintaining that particular software, what happens is the software that is developed in your development environment might not work in the production environment. And one of the reasons for that is probably the change in environment in which you're running the software. So this is not the case when you use containers. Why? Because a container is nothing but it is a limited object, or think of it as a limited box in which you only have your binaries, in which you only have your application details or code. So basically when you pick up this container and if you run it on any machine that supports Docker, probably your image would run the way it ran. So testing your images, or rather your applications, becomes much easier when you use a container. So this is what Docker is, and this is what it lets you do. So by now we've already discussed what Docker is, we've understood what virtualization is, and we've gone through what containerization is. The fact that we are talking about Docker and we are talking about using it on AWS, let us try to understand AWS a little more so that we can probably relate Docker with AWS a little better. So what exactly is AWS? So when you talk about AWS, it is Amazon Web Services, and it is one of the most popular cloud service vendors that are there in the market. Now, what is a cloud service vendor? I just talked about creating applications, running applications, hosting applications. So if you do it on a private infrastructure, the structure actually becomes little redundant, or I should say little stagnant, because scaling up becomes an issue, maintaining servers becomes an issue, and it becomes a costly affair as well. Instead, if you could rent these services and let somebody else maintain it for you, the affair becomes a lot cheaper. And that is what cloud computing and cloud vendors do. They let you rent these services, that is your compute power, database, storage, content delivery, monitoring, machine learning, and a number of other services, and even container services these days. So why AWS in particular? Now AWS is one of the leading cloud service providers in the market, and it has the highest market share when you talk about cloud computing. So yes, when you talk about containerization as well, it did pick up steam in like last 5 to 10 years, and that is why AWS also decided to incorporate containers or Docker and Kubernetes in their infrastructure. What happened and how did all these things happen? Let us just move further and try to understand, as in how did AWS did take in Docker approach as well. Now these are two of the key services when it comes to containerization or hosting Docker applications basically. So what happens here? If you go back to somewhere around 2013, containers were actually catching steam and people wanted to use containers. At the same time, AWS, as we all know, has been popular for a while now, maybe a decade or so. So yes, people were also using AWS and they wondered, as in, can AWS be used to use containers? And AWS replied in 2013 saying that yes, you can definitely use containers on AWS as well, Docker on AWS as well. And how? The answer to that was Amazon ECS, that is your Elastic Container Service, EC2 container service. Basically, you can call them by any name, both are kind of correct. So when you talk about ECS in particular, what it does is it lets you take care of quite a few things when it comes to containers. I mean, it lets you create clusters readily, it lets you have certain operating systems or certain instances or environments in which you can actually host these clusters, on top of which you can run multiple containers. But then the problem with ECS was there were certain dependencies where the user had to get involved. I mean, when it comes to auto scaling is a process where you want your application to scale automatically. So you had to set up auto scaling so that if the traffic on your applications increase, that can be handled or balanced. But what this did was this actually made anomaly or created a problem where people were actually dependent on Amazon Web Services or ECS to certain extent. So people actually wanted something that would take care of this anomaly as well and make the process of only maintaining the applications and creating the applications as the primary task. So this is when they introduced Amazon Fargate, somewhere around 2015ish, 16ish. I do not remember the exact year, but this is when it happened. And in that phase, what they did was they actually did go ahead and ensured that you were no longer responsible for taking care of your auto scaling and all those things. And what this did was they actually did use in the environment for Amazon ECS, but using Fargate, what happened was you were not required to worry about the instances that you create and all the underlying architecture that probably required your intervenience or basically your participation. So all you had to do was use Fargate, create clusters, containers, and directly work on your applications without having to worrying about all these pointers. Now, as I move into the demo part, I would be talking about quite a few terms like instances. We would understand what EC2 is, what compute services are, what Amazon Fargate is, what ECS is. So if you've missed out on certain pointers and not understood those, do not worry. As we get into the demo part, all these things would make a lot more sense to you people. So let us not waste any time and quickly just switch into the demo part, shall we? So guys, this is what the AWS console looks like. Now, again, for people who are completely new to Amazon Web Services, let me tell you one thing that Amazon Web Services gives you a free tier account using which you can actually go ahead and do quite a few things. You can understand how cloud computing works. You can actually host your applications. You can load balance those, scale down those applications, and a number of other things. You can set up networks. You can actually create security groups, make sure that all these services are secure, and quite a few other things. So yes, for people who are completely new, I would suggest that you actually go ahead and create a free tier account on Amazon Web Services. Now, these services are made available to you for free for one complete year. Yes, what Amazon Web Services does is it probably gives you certain services for free for certain duration, and if you exceed certain limits, only then you are charged. Otherwise, if you stay in the limit, you would not be charged for one complete year, and which I believe is more than enough if you just have to go ahead and practice these services or get sufficient hands-on on Amazon Web Services or cloud computing. So again, if you do not have an account, just go ahead and create an account. Do you need any details to create this account? Probably you'd have to visit the console. Just type Amazon Web Services console or Amazon Web Services free tier, and you can click on the first link that is available and you would be redirected to this page. This is not what it would look like. Instead, what would happen is basically a sign up page would come in where you'd have to enter your email ID, maybe what is the purpose that you're visiting this particular website, and probably they would ask you to enter in your credit card or debit card details. Do not worry, AWS won't charge you without your consent, and probably you can set in your alarms as well so that you do not exceed the limits that you use. So having said that, I would want you all to have an account on AWS because it is a very fun and nice platform to work on. So once you do have an account, this is what you have at your disposal. let's have a quick introduction to what are the services that are here and what all can be done with it. Once we are done with it, we'd probably jump into the Docker part and we would see what we can do with Docker on Amazon Web Services. So guys, as you can see, there are quite a few services here. There are compute services. You have your EC2, Lightsail, ECR, ECS. We would be using ECS today, and to some part I would be talking about EC2 as well, which is your elastic cloud compute. I talked about virtualization, right? So what virtualization does is basically we create virtual machines. So cloud computing, or AWS in particular, lets you create virtual machines as well. And instead of calling them virtual machines, we call them instances here. So you can launch multiple instances, or basically environments on top of which you can run applications. So one way to actually go ahead and host your Docker applications or containers is you can actually launch an EC2 instance, and on top of it you can actually go ahead and probably install Docker and then host containers or have containers which you can run to run your applications. So that is the old school method, where your EC2 acts as your system on top of which you're gonna go ahead and play with your containers. The other way is your ECS and AWS Fargate. Now these services, what they do is they completely cut off the process where you have to go ahead and spawn an instance on top of which you have to create security groups and do a number of other things. So in this session we would be doing both the things. First I would show you certain things, as in how do you get started with your Docker in EC2, and then I would switch to Fargate so that you understand Fargate in a better way and you understand why do we actually need to use Fargate. So let us do that. Let us just go ahead and launch a simple virtual machine. Not a virtual machine, rather an instance using EC2. So if you click on EC2, this is what you'd be redirected to. You can launch an instance by clicking on this icon. So as you can see, in the marketplace you have quite a few options. You can choose AMIs. AMIs are nothing but images. Basically when you create a template or create an operating system, it has a by default template which AWS saves as in the form of images. So these images are nothing but templates for your respective environments or operating systems which you might want to use. Now when you talk about Docker, it has to be on Linux. I mean, yes, there is a way you can do it on Windows as well, but preferably it is Linux. So let us just go ahead and launch a Linux instance first. So this is a free tier eligible. That means I won't be charged if I launch this instance. So I do that. And then there are certain details. What is the family of your instance? There are quite a few families. You have T2 micro, you have various other actually families which you can actually go ahead and explore. Now again, if we keep discussing those families, this session would go too long. So let us just stick to the basic or the free tier resources that we have. You can actually go ahead and explore these resources if you want. If I go to the next button and I click on it, it would show me some other settings. For now, my main concern is this part. Yes, the security group. So when I launch an instance, I need to log into my instance to maintain security. So you have certain security groups which ensure that these are the rights users have when they try to access these kind of instances. So we need to actually go ahead and set up a security group to some extent. So there is one rule which says that I allow traffic from SSH. Protocol here is TCP, and this is the port it is using. I can actually go ahead and add one more rule. I can say HTTP. There you go. And allow traffic from anywhere basically. Now I can say review and launch. In order to sign into my instance, I need a key pair, which is a security measure. So I need to create a a key pair rather. And make sure one thing, guys, that if you do create a key pair, you save it properly. So say, let us name it, say Sam new. I'm very bad at naming conventions, guys, so please forgive me for that. Again, guys, you have to take care that this key pair is well maintained. You do not lose this key pair. So if you do create one, you just need to save it somewhere. And then I say launch an instance. So guys, what is happening here is my instance is getting launched. So once this instance gets launched, I can actually go ahead and install Docker on top of it, and do quite a few things with it. Now the reason I'm going through this drill is because I wanted to understand what is happening here. So this is like basically going ahead and just creating an instance on top of it, running your Docker and doing all those things, which was very relevant say 3-4 years back. Now there are better ways to do this, but first let us see how do we do it in this particular way. So if I go back to services, I go back to EC2, you can see that an instance would be here saying that there is a running instance which I just created. Let us see whether that instance is launched or it is still getting initialized, guys, but that is not a concern. I can connect it to or connect to this instance. So guys, this being a Linux instance, I need to actually go ahead and use a key to log into this instance, and this being a Linux instance, I cannot use this PEM file. It needs to be in PPK format, and to do that we have a software. If you do not have this software, you can install this. It is PuTTY. So you have PuTTY software which lets you use this key or convert this key, and to generate a PPK key you need PuTTY Gen as well. This is the other software. So what you do is you just click on load and you select the file that we just actually downloaded. So it is not here because it is in different format. You can see PEM. I say open, and always save a copy of this key, guys. Do you want to save it? Yes. And what should be the name? Let's say sample12. I say save. So the key is saved here. Now I can actually go ahead and launch my instance. First let us confirm whether our instance is up and running, whether it has initialized or not. Okay, it is still initializing. Let it get initialized, and once it is done, probably we can actually go ahead and connect to this instance. At times this can be troublesome. I mean, you have to wait for certain things. So guys, again, as you can see, I've launched an instance. The launching process is taking time. When you talk about virtual machines, which I mentioned, it takes a while. Why? Because it boots in a guest operating system, and hence this time. I mean, the checks, the quality checks, the initialization process, all these things, they can take a little longer while than normal. Okay. So meanwhile, just let me tell you what we have to do. The fact that we have a key now, probably we can actually go ahead and connect to this instance by using this PuTTY configuration. You have to enter in your host name, and you have to enter in that PPK file as well. So let us see whether these status checks are complete or not. Yeah, as you can see, the status checks are complete. So when I say connect, I get certain details. Now these are the important things. This is the stuff I need to copy. There you go. And I paste it here in this host name. Okay. And then I go back to this place. I click on data, and here if I come back, the first part before at, I can copy that and I can just come here and paste it here. Now I need to actually go ahead and select the PPK file which I saved. So to do that, I click on SSH, and in that I click on authorization. I browse, and here is the file. I say open. I say open. Yes. So guys, what it has done is it has launched a virtual machine on top of which I'm gonna install Docker now. How do we do that? First, let us check whether I am the right person or I have signed in as a right person. Yes, EC2 user, this is me. So I should say sudo yum update. Why? It would get in the necessary details that are needed to install Docker on top of it. Okay, it is almost done. It should be done soon. There you go. So next what we do is I say sudo yum install docker. Okay, I made a spelling mistake here. So when I go ahead guys, what I can do now is I can just say sudo service docker start. Okay, I'm not doing it fairly well today. Sudo service docker start, and there you go guys. It has configured your docker service here. So guys, this is about configuration. I mean, back then when containers were new, this was actually still very fast and very effective, but as I've already mentioned, there are faster ways to do it. Now by now what we've done is we've just installed an instance, and on top of that instance I've actually installed Docker. So that is the only thing I've done. But if I do it using certain services, this process can be speed up like anything. I mean, you do not have to worry about anything. Here we haven't created a cluster, we haven't done almost anything. So let us just go ahead and use one of the services, as in your ECS or your Fargate. Let us see what we can do using those services. So let's just close this for now. Yes. Again guys, one more suggestion: if you do have your instances or services, make sure you terminate those, because that actually helps you basically save any costs that you might incur. This being a free instance, that wasn't the case, but still let me just shut it down. I've done that. Now I'm gonna go to ECS. This is a fresh account, so you do not have any applications running here. So let's just say get started. So guys, this is what we are going to do. We're going to go ahead and create an image that is basically your container definition, as in your basic code, your application, whatever you want to run. In this case, we would be using a sample application. Then we would be having a task definition, where this task definition, what it does is it has some other attributes which are not there in my container definition or in my image, to manage my so-called containers or to run my so-called containers. And then you have your service, which tells your cluster or your Docker daemon rather to run a particular container image and use a particular task to do that. So we would be doing all these things, and we would be creating a cluster, and let us see how long it takes now. So guys, there is a sample application. You can actually go ahead and edit. You can use any kind of container definition you want. You can customize it to meet your needs as well. You see there's an option here which says customize. You can do that as well. For now, let us use the basic application, the sample application. So that is selected by default. Task definition guys, again this would be basic or by default. You can make changes here. You can change the name, you can decide what network mode to use, you can decide what execution role you want. If you have any role, you can actually assign that particular role, where you can assign particular properties to it. And what are the compatibilities? In this case it has to be Fargate, because I would be using Fargate, and this is the task memory that is allocated by default. So let us stick to those configurations, because we do not want to get charged unnecessarily. So yep, this is what it is. I'm gonna say next. Now it says define a service. A service allows you to run and maintain a specified number of simultaneous instances of a task definition in an ECS cluster, something that I told when we did get started with this particular topic. Number of desired tasks, you can change it, you can edit it, you can have multiple tasks, just to be secure, so that if any of these tasks it goes down, if its health is low, you can actually go ahead and use the other task as well. But in this case, again, let us stick to one task only. Load balancer, if your website experiences high amount of traffic, you can balance that by using a load balancer. Let us create one for sample. So it would be using this port as the listener port, and protocol would be HTTP. So I say next. There you go. And then it says configure your cluster. Should I name it something? Let us say today's cluster. Again guys, I'm very bad at naming conventions, please forgive me for that. You have a VPC ID and subnets which it automatically creates. You can let them do it for now, because again this is a basic application. So I say next, and it asks me to review all these things. For now I'm gonna say create, because I know what all details I have entered. So as you can see guys, it is spawning a cluster and a container for me. And now let us see how long it takes to spawn a container. Now guys, there are 10 processes that are happening here, 3 of which are done. And let us see how quickly the other processes also take place. Again guys, in this case, we are not worried about anything. I wasn't concerned about probably creating security groups. I wasn't concerned about creating a virtual machine. I wasn't concerned about using EC2. I wasn't concerned about anything. My only concern was what is the cluster I want, what is the application I want to run on top of it, what is the image I'm using, and all those things. The basic information. And once you enter that basic information, your cluster would be created. Again, creating your images won't take that longer time. Yes, creating clusters might take. Now your cluster can hold multiple containers as well. So yes, certain processes might take a while. So in this case, we can see that 7 services are complete out of 10. Probably we are left with 3 more to go, which should be done very quickly, I'm sure. Maybe say half a minute more. One more thing guys, once we are done with all these applications, creation of these applications, ensure that you actually go ahead and delete all the resources that you're using and all the services that you've used. And meanwhile this gets done, let us just quickly see something else. If you people are interested in a structured training, now again on our YouTube channel we have quite a few videos that talk about these things in detail. Even if you go through those details, probably you would be in a good state to actually go ahead and start with any course that we have at Edureka. But if you're looking for a structured training, probably Edureka would be a very good option guys. The reason for that is the prices here are very affordable, and those are in real time. I mean, if you do participate in some of our competitions, you might get more discounts, and this price might seem very less. It is in Indian rupees. For dollar price, you can actually call our help center number, and probably they would assist you in a much better way. So this is a 4-week course, and you can see that these are the modules that are covered here, which you are free to actually go ahead and take a look at. So if you're interested in AWS and DevOps kind of a role, probably this is a very good course to take. Apart from that guys, AWS or Edureka rather provides you with a certification as well, which holds a lot of value in the market. And then they have this 24/7 support. They have their LMS where you can access all these resources for lifetime, and a very helpful support team that actually answers all your queries right away. Having said that guys, this was about your personal choice. You're free to decide on this. Let us just go back and see that whether it's completed, and you can see that our process is complete and it is up and running. So guys, let us view this service, what it has to offer to us. There you go. These are certain details. You have your task definitions. Again, Amazon EKS is something that you can use for Kubernetes, which is again a container service. This is not the topic of discussion today, so I did not get into details of this particular topic. But when you talk about this particular topic, or creating your cluster is concerned, we have one with us, and there are the details, or here are the details about that particular topic. You have your tasks, the tasks that are running. There you go. It is still pending is what it says. Then you have your events. These are the events, your auto scaling groups, your deployments, and all the details that you need. So if I go back here and I click on this particular icon or the link, it would redirect me to this page. And if I scroll down, you can see that I have a load balancer. If I click on it, I have a DNS name here. I copy it and I paste it here. And there you go. It says that I have a sample application and it has been deployed by using a container. So it has created a container. On top of it, it has run this simple application. Now there is nothing much here, basic code, so you don't see anything too real time or too interactive, but there is enough of an evidence which says that an application has been launched and it is running on my container. So there you go, guys. This is what it is. Probably you have all the details. You can just go back and take a look at other things as well. If you wish to explore these services a little more, you can always do that. So let us just say ECS, and now it would show my cluster here, today's cluster. It was a very bad name, but forgive me for that. Yep. So guys, now that we have all these things, again, if you are doing this for experimental basis, I would suggest that you delete all these things. How do you do that? You click on this icon. First thing that you do is you say update. This is just a security measure. Number of tasks, set it to 0 so that even if you miss out on deleting these, you won't incur too much damage. And then say update. Now that I've updated this service, I can go back and I can just say delete. How do you delete it? You say delete me. And then you say delete. There you go. And it has been deleted. Again, what do you need to delete? You need to delete your cluster as well. So say delete, and the cluster would be deleted. It might take a while to delete your cluster. Before that, okay, let's just delete the cluster first. So once the cluster is deleted, guys, your next step is to actually go ahead and delete the load balancer as well, which again is not that difficult of a task. So guys, we are almost nearing the end of today's session. Once we are done with the deletion process, probably we would be bidding adieu to each other. Please let me know in the comment section how did you feel this session was. If you did like this session, please hit the like button and stay tuned with our Edureka channel, because on our Edureka YouTube channel we have quite a few sessions, quite a few videos that go live almost every day. And if you are somebody who likes to learn, who likes to explore new technologies, understand what is up to date in the market, probably you would have a lot of things to digest, a lot of things to learn when you talk about this YouTube channel. So the previous tech probably took a lot of time. As you can see that from 4 to we are just on 5 right now. Probably that was the process which took a longer while to delete. Now we are on 9. Probably we should soon reach 15. There you go. And the cluster is deleted, guys. Now we go back to EC2 console and let us hope that our load balancer is also deleted, because I deleted the application. So with that, the load balancer should also go. If not, we would delete it manually. Yes, it has been deleted. So all our resources have been deleted, guys. We've actually gone ahead and understood what containerization is. We've understood how Docker works and how you can actually go ahead and create a container, a cluster, and launch an application using AWS. and all this happened quickly because of Fargate, and we saw that EC2 took a longer while to do that. So I believe I've talked about quite a few things, and um, I hope that I've cleared quite a few myths that you people had about Docker and virtualization. If you do have any queries, you can share your email IDs with us and we'll get back to you as soon as possible. As far as this particular session goes, guys, I would be resting it here and here. Thank you. Bye bye.